Okay, now let's consider the function y minus 4 equals 0. So that's the same thing as saying that y is equal to 4. That means all the values are 4. Now if I make a table of this, x and y, I can put in numbers like -1 and I get 4, 2 and I get 4, 0 and I get 4. But notice how the input is always different and I get the same value. That actually is a function. So this is a function. And I'll show you a really cool way of actually visualizing when something's a function and when it's not. Now, if it's a function, I have to tell you the domain and the range. Well, the domain is all real values because I can put anything in there. Now, how do you write all real domain? How do you write all real numbers? It's from -infinity to infinity. But your range, on the other hand, that is just 4. And it's a single set. So again, if you use your set notation, that's just 4. That's a bad-looking curly brackets. Okay, a linear equation, ax plus by plus c is equal to 0. And if a is not equal to 0 and b is not equal to 0, then we can go ahead and write y as equal to -a over b. We can do that because, again, we're not assuming it's equal to 0. X minus c over b. Now, this is of the form, it should look something like y is equal to mx plus b. If you remember what that is, it turns out that this will be your y-intercept and this will be your slope. Now this is a function. This is a function. And the domain, again, I'll use a d for domain, goes from -infinity to infinity, and the range, I'll use a little r, is also -infinity to infinity. All right. Does the equation y squared equal to x, is that a function? The answer is no, it is not. No. Why is that? Well, if you consider, let's just try something. Let's say, let's let x equal to 4. Then y squared is equal to 4. So that means that y is equal to plus or minus 2, or the square root of 4. So that means I have the point 4, comma 2, and 4, comma -2. Now I want you to think about what this means. This means that f maps 4 to 2, and it also maps 4 to -2. That doesn't make sense. You can't have a function mapping the same thing, having the same x value. Now let's consider the graph. If I go over here to 4 units, 1, 2, 3, 4, and I have this line right here, you'll see that here and here, this is my -2, and that's my 2. You'll see that there's a vertical line. It actually passes through the vertical line twice. So this is the point here, 4, comma 2, and this is the point here, 4, comma -2. It's not a function. And we'll talk about what that means as far as the vertical line test. Definition. The graph of a function f of x is the set of ordered pair x and y in the coordinate plane such that x is the domain of f and y is equal to f of x. So we've already given hints to this. As we've seen, not every graph represents a function. The vertical line test is what I alluded to in the previous page. This basically says that a graph y as a function of x if any vertical line intersects the graph at most 1 point. So it can't graph it at any more, then it won't. Now these two examples, this is a very important example because it sort of shows you the importance of the notation here. The first one here, I have x squared plus y squared equals 4. So for this one, I can write that y squared is equal to 4 minus x squared. And so then y is equal to plus or minus the square root of 4 minus x squared. So I have 2 halves to this. This is basically a circle. You should be able to recognize this is a circle at the origin with radius 2. So if I come over here, I'm going to have my points, and then I'm going to draw a circle here. This is going to be very hard. I'm drawing this with my finger, and not too bad. That's what this first representation is. X squared plus y squared equals 4. Now the second one, this is just the lower half. So this one is just, if I go from here to here to there, just like that. And again, I do include those points there. So the difference between the two is that this one is not a function because it fails the vertical line test. And again, if I draw a vertical line, at any point, it fails. It's going to touch twice. Over here, this is a function, because no matter which vertical line I draw, it only touches it at one spot. So this one is a function.